Good afternoon, folks. Chief Meteorologist Nick Lilia here, hanging out in the Severe Weather Forecast Center back in behind the set, taking a look at the weather as we head through Friday and into Saturday and kind of lingering around into Sunday morning. But like always, the closer we get to one of these events, the smaller that window gets that we're looking at the chance for showers and storms. Right now, the latest from the old weather computer over here, as well as a couple of models that I'm about to show you, do hold on to a chance for rain starting Friday, some elevated convection, which means no surface-based guys. Don't have to worry about tornadoes necessarily on Friday, but on Saturday it looks like we may have to. So we're going to start off like we always do, way up there in the atmosphere, and we're going to hang out at about 300 millibars or so, and we're looking for those spreading of the isobars. That would be these little black lines in here. What we're wanting to see is an area where it starts off kind of skinny back here and then kind of widens out here. And I would argue that we have that. Of course, let's get in here real close. There's the coastline of the landmass from southern Mississippi, at least. And then we can go ahead and make out the state of Mississippi. Kind of a rough sketch. But it looks like, you know, that's spreading aloft. And then we can maybe draw another line down here. It doesn't look like we got much there. But that's spreading aloft. Does look like it happens to be across parts of central and northern Mississippi. I'm going to leave that circled for a quick second. Now we're going to look at where where we got the most vertical velocity, and that's a change in wind direction vertically rather than horizontally. You know, we always talk about, oh, we've got a north wind today, an east wind today. Well, up there in the atmosphere, there is a vertical wind as well, though it's pretty slow, as parcels of air tend to just kind of meander along off, well, away from the Earth. They've got to battle with gravity, of course. And usually you're talking about a pretty strong vertical velocity when you get about 6 centimeters per second upward. And that would be negative, too, because you're losing pressure. Don't worry about the math, but this is decapascals, and that ends up being, if I do my math correctly, 6 centimeters per second, kind of in the 30 to 40 range. And if you look in that little circle again, looks like we've got that. So we've got some vertical velocity happening as well. Again, that's at 700 millibars. We'll go ahead and take a look at the 500 millibar vort, and there's some energy right there for you. I'm going to clear that out, and I'm going to recircle this area again. Again, that's the area where we've got the spreading aloft. We've also got some vertical velocity. Now we're just looking at the vort because it's fun. And now we'll look at dew point at 850 millibars. So again, we're moving down in height. 300 millibars way up there. And then we go move down. We're at 500, or we're at 700, then we're at 500. And now we're down at 850, at 500, 700, 850, because you go down, the higher up your number goes. So here we are at 850 millibars, hanging out at about 3,000 feet or so, 4,000 feet. And we've got plenty of moisture coming in off the Gulf. Holy moly, do we ever. The good news is here, we've got a southwest wind at 850 millibars rather than a due south wind or even a southeasterly kick, and I'll explain why that's important here coming up in a couple of minutes. But we'll have plenty of moisture, and you know, it's off the scale on the side of the screen here, but if we kind of zoom up, clear that off, we kind of zoom up here, we're talking about a dew point at about 15 degrees Celsius or so, right in this ballpark here. And again, that's at 850 millibars. That's the dew point that we're looking at. And come down to the surface. What does that mean for the dew point at the surface? How about anywhere between about 60 and 70 degrees? A 70-degree dew point really hugging on to the coast. Though I will say, this would probably be the first time we'd see a 70-degree dew point inch its way northward, other than directly on the coast, for at least the last, I want to say, month and a half or so. And at the surface, we've got southerly or almost a southeasterly kick. So what ends up happening is you get all that moisture at the surface, and then you're able to warm that up with either the sun, or you're just warming it up because the air is a little bit warmer than the air above that, so you end up with instability, and that's CAPE here. That's just the measure of instability. And you want numbers down here in the wintertime, at least, with these in the cold season, up above about 500 to 750 or so. The green line right here, and points off to the south, if you head over here and kind of take a look, or about 1,000 or so south of that. So we'll have the instability that you need for severe weather. Lifted indices here in the orange and the darker orange are here at least -5 or so. And again, this is according to the GFS. And then we look at shear, and anywhere north of this blue line here, you're at 30. Anywhere north of this blue line here, you're at 40. Anywhere north of that line right there, you're at 50. And, you know, if I go back and I want to circle that same area again, and I want to cruise right ahead and look at the lifted index. It looks like most of the lifted indices are down off to the south of that, as is the instability. But that is kind of where the most shear is in terms, I mean, you're out ahead of everything, but that's where we've got a decent amount of shear and a decent amount of helicity. Now, that kind of almost bisects our area. That would be our northwestern zones with the most helicity, the most shear, the least lifted index indices, and the least instability for the area. So we'll be watching, kind of towing the line, maybe a lot like the storms did a couple of days ago, almost a week ago now, where we dropped a tornado that dropped in parts of Louisiana and moved off northeast across the area. Am I predicting a tornado? Not at all. But I am saying that the ingredients are there for tornadic weather, unfortunately. And we can go over and take a look, and I'll bring myself back here. Hold on a second here. I'll slide this up for you guys. We'll go back and go ahead and take a look at all the math. For all you math people out there that are really interested in this stuff, what we do is we take all that information we were just looking at, and again, we're moving down into through the atmosphere, 200, 300, 500, 700, 850. And you start at 500, you look at the temperature, the wind, and the wind direction. And the wind direction, by the way, that would be if you're looking at one of these and you've got 0, 90, 180, and 270 here. And you're taking that wind direction and you're saying, okay, it's kind of doing one of those. And so you say, okay, so that's about 40 degrees or so. And so you end up with a 220. And that's how you figure out these numbers in here. So you've got a southwesterly kick at about 500 millibars, moving at about 55 knots or so with a temperature, and this is in Celsius, at below 11 degrees C or so. And right now, all we're looking at, clear that out, right now all we're looking at is the GFS, the NAM, and the SREF. The HER doesn't come out, it won't give us numbers until the day of. The WRF, we got to wait one more day to get information from the WRF. I went ahead and estimated some numbers, but I made it really small so you guys couldn't see it, so it wouldn't confuse you guys. So in GFS, NAM, and the SREF, the forecast we'll talk about here in a second. So we're looking at temperatures between 11 degrees and 13 degrees below zero. At 700 millibars, we're looking at temperatures about 5 degrees or so. We're talking about a 40-knot wind or so out of the same direction, again, that southwest wind. And then as you move down to the atmosphere at 850 millibars, we were looking at 15, 13, 13 with dew points just above 10 degrees or so, according to the models, if you're looking at the estimated sounding rather than that map that we were just looking at. And down here at the surface, and again we can do that up again, about 200 degrees or so. So you're looking at from 180 here, you're looking at 200. So you're looking at 20 degrees just to the west of due south. That's good for us at 850 millibars. What you don't want down here is something like a wind that's coming straight out of the south, or maybe just slightly out of the south and east. And now the numbers aren't perfect here, so this might not work out how I exactly want it to. But if you look at this this sweat number down here, right there, and you look at over here, I want to point something out really fast, and we can play with these numbers in here. But 200 degrees, right, that's just out of the south. If you had a 180 down here, looks like we would lower the number. Okay, so that's interesting. Usually, if you have something out of the due south, or maybe it's even kicking around a little bit closer, we can go, how about 170 out of the south and east? 165 maybe? No? Okay, well, usually, generally speaking, when you don't have to do this on the internet and you're not doing something on the spot, when you get winds a little more out of the south, it tends to, as it intersects with those storms, tends to give it a little more helicity, and it tends to make those storms have the possibility to turn a little more severe. didn't in this case, of course, because Johnny on the spot here can't make things work the way that they need to. Okay, so if we take a look at all of these models and then we average them all out, you end up with a whole bunch of numbers on this side. It's almost like we're running our own ensemble, the mean of all of these. Surface Cape right now between the models looking at anywhere between 750 and 1400. 3 kilometer shear up over 30, 6 kilometer shear for the most part up over 50. Helicity, one thing interesting, usually in the cold season down here, we get a lot of helicity coming out of these storms, anywhere up over 200, 300. Last week, I think it topped out around 350 or so, which is quite a bit. This week, models are indicating about 200 to 250. Last week, they were indicating around 300. We ended up on the top side of that and close to 400 at times. So this week, coming in at 250, I think that's going to be a little low. But again, we'll get to the forecast here in a second. And the EHI down here, and you can look at the legend here, right there. The EHI basically just is Surface Cape divided by Helicity times, or Surface Cape times Helicity divided by 160,000. Don't worry about the math. Again, just look at the legend here. Anywhere between about a 1 or so and just over a 2. So that'd be right about there. F2s and F3s possible. And again, that's about the numbers that we had last week when we had the EF2 and the EF3 tornadoes. Okay, so you get all this information, you stick it into a bunch of wonderful categories, and you go through and you kick out a bunch of, here you go, there's the old formula that we use to figure out some of these numbers, and you end up with these numbers that mean nothing until you compare it to the key over here. So the sweat, we're at 426 on the GFS, 394 on the NAM, and 406 in the SREF. What does that mean? Well, you look right here. Generally speaking, you have tornadic cells that will be possible, not likely, possible, if all the right ingredients come together. Then you look at your total totals. Anytime we got 50, 49, and 50. So we've got thunderstorms likely. Total totals here, not incredibly impressive. Last week, we were in the 53 to 56 range, and I think we had a couple models come in greater than 56. So at least this week, the convective potential is a little bit lower. Same goes, we've got a couple of 33s down here, and that's moderate convective potential. If you go back and watch the video from last week, I mean, we were 40 plus on almost every single one. The BRN down here hanging out in the 20s and right around 15 or so. Teens is optimum. Supercells favorable anytime you get below 45. So we're looking at the opportunity for supercells, the opportunity for tornadic storms. Then you take those numbers, you take a look at the SREF here, but you're looking at different parameters. Now what you're going to do, what we do, is we look back in history at the tornado environment browser that's put out by the SPC, and we take a look at all of the statistics that they've gathered for tornadoes going back, I think, about 10 to 15 years or so. The historical average for the significant tornado parameter, that's the STP, has 0.1 to 1.5. We, according to the SREF, will be at a 1. The supercell parameter, between a 1 and a 6, will be at a 3. Mixed layer Cape, between 250 and we just go right down the line here, and we fall into the historical average on all of these for tornadic history. So, knowing that, looking at all the models, the forecast that I'm looking at right now and thinking is, I've got a feeling that we will be a little bit cooler aloft. Not much, but just barely cooler than the GFS and the NAM. The SREF, I think, is kind of spot on here. 50 knot wind at a 220, I think that's probably pretty good. 700 millibars, I think we're going to be up at about 5 degrees, but I think we'll have a little more moisture because we'll have enough vertical velocity, and as we'll see in a second, I think our dew point's going to be a little bit higher. That gives us a dew point depression of about 2 or so. At 850 millibar, I think we're going to be at about 15. I think the GFS is pretty close. Better than the NAM and the SREF right now, because I think that warm front is going to lift far enough to the north early enough to start to mix in some warmer temperatures. On top of that, as we saw on that map just a couple of seconds ago, we had dew points on the map at least that showed above 12, 13, 14, 15. Most of the models coming in, the raw data coming in, saying 10 or 11. I've got a feeling we're going to be a little bit closer to 12, 13, 14. The reason that that is so important, we can take a look at this sweat again. If we're down at 10, we're still tornadic possible, but if we're up at 13, that jumps almost 100 points. Now, again, once you get over above 400, that doesn't mean very much. But, you know, if we came in and we were drier, say that warm front didn't pull as much moisture, say we're a little bit drier, we only have a dew point of 8, 355. So the drier we become at 850 millibars and then here at the surface as well, if there's not enough moisture to get things really going, that does lower the threat for severe weather. But unfortunately, I just got a sneaking suspicion that we're going to be up around 12 or 13, and even at 12, you're at 483. And with winds, I think it's going to be around 200. I think these are pretty... All of the numbers in here for 850 millibar wind and wind direction, I think, are pretty good. So you end up with these numbers right here. And how do those line up? Those guys right there, 54, 39, and 25. Well, 54, unfortunately, widely scattered severe. 39, unfortunately, just shy of a high convective potential. And we're down there at 25, which is good news. Supercell's favorable, sure, but we're not at least in the optimum category here for any severe weather. The 515, of course, anytime you get above 400, you're talking about the opportunity for tornadoes on the sweat. This isn't all we look at, though. We look at a whole host of other things. The SIPS analogs from St. Louis University as well, which I didn't dive into on this guy this time, and as a host of other things as well. But this kind of gives you an idea, I think a really quick idea of what we're looking at over the next Friday into Saturday. And again, Friday I don't think we see any severe weather. Saturday I think there's severe weather possible, with tornadoes possible. But right now I think our low-level spin is the only thing that's maybe holding us back, because this time we do have the shear, we do have the instability, as it looks like. It's just the helicity is a little bit, it's down, though, like we were just showing, historically speaking, we fit into all the categories to get a tornado. And honestly, folks, I wouldn't be surprised if we saw one. I'm hoping right now that everything doesn't line up the way that it's looking right now, and we look at more of a straight line wind event. That means we have all the winds coming out of basically the same direction all the way up the column of air. The cold front kind of overruns everything, and we end up with either a westerly or even a northwesterly kick back in behind it with all of these storms, and we don't necessarily have to worry about as much in the way of severe weather and as much in the way of tornadoes. But again, folks, I mean, I hate to be brutally honest with everybody, but I would not be surprised if we saw at least one tornado warning out of this setup as we move into the day on Saturday. So that's the latest we know right now, Wednesday at about 4 o'clock or so. And again, I'll post another one of these hopefully tomorrow, but most certainly on Friday to give you guys an update as you work your way toward the weekend. By the way, one thing I didn't say at the beginning, and if you made it this far, you get 5 points again. But Happy New Year to everybody. I hope you make a good New Year's resolution. Have fun tonight. Do it safely, please. Get a cab home if maybe you've been enjoying it too much, please. And hopefully we will have a very good 2015.